So we've discussed the design process, but now we look at design communication, because as you're working through the design process, you have to have a way to effectively communicate your ideas. And in architecture, when you're going through the design process, there are several fairly standard and maybe not so standard tools that you use to communicate your ideas. So any of those tools that you use we refer to as design communication. Now, architects, depending on what their skills are, what their preferences are, they may use any or all or maybe some other that I haven't mentioned or I won't mention tools of design communication. But the key here to remember is that these are just tools. So all you're doing is you're just trying to communicate your ideas to somebody else. If you were only communicating your ideas to yourself, then you could have just super messy sketches and then somehow it would get built. But that's not really what happens. You need to communicate your ideas to those others that are working on your project team. Maybe it's other architects in your firm. Maybe it's even to yourself, but it could be engineers, to the client, other owners, maybe other people who have a vested interest in what the project looks like or how it functions, like the neighborhood or other people in the community. You could be communicating your ideas to the contractor, and so that becomes really critical in terms of the accuracy with which you communicate your ideas. And so we'll look at many of these tools and just think of them as, like any other actual tools that you would have. Like if you had, a hammer and screwdriver and a saw, right? You're going to use different tools for different situations. So that's the same thing in design and the same thing in architecture. You're going to use different tools for different situations, and some things lend themselves to some tools, and depending on what you decide to use, it might lend itself to other tools. So really we're talking about visual representation. Architecture is an extremely visual profession and an extremely visual field of study, but we're talking about really accurate visual representation of your project also helps you more clearly define what your design ideas are as you're working through the design process, but it also makes sure that there is less ambiguity between what you are trying to achieve and what your client thinks that you're trying to demonstrate. So the more clearly you can represent those ideas visually, the better understanding others hopefully are going to have of the design intent, the design concept, and your overall design scheme. When we talk about design communication, often we talk about metacognitive skills. Now, this is especially critical when you're first learning to make drawings or use any of the other design communication tools that you're going to be using hopefully for a long time. Now, if you've never used any of these tools before, that's okay. The idea of a metacognitive skill or metacognition, it just means you're thinking about thinking, right? You're thinking about what it is that you're thinking about. And that seems a little redundant, but when you are using these tools to communicate, the process of creating the communication devices, I guess, whether they're drawings, whether they're models, whether they're, photo collages, or whether they're renderings, the process of the designer creating those communication tools or using those communication tools also helps you to synthesize your ideas. It gives you feedback about what the design actually is. And so design communication can act as its own design process. And so, yes, you're going to go through the design process and create ideas and brainstorm, and then you're going to prototype. But in that prototyping, as you create all of these, whether they're two-dimensional or three-dimensional prototypes, the metacognition that accompanies that is going to help problem solve also. So we look at kind of two basic areas of design communication. There's two-dimensional communication. This is a Piranesi drawing, and Piranesi, beautiful kind of watercolor and hand-drawn perspective drawings, and they are very evocative in terms of their mood and lighting. So, there's all kinds of things that we can get across as far as design intent with two-dimensional representation. Now, I say drawings, but this is effectively a painting. So there are all different kinds of things that we could do with two-dimensional design tools. So one of those is sketching, and sketching is a great metacognitive skill, and it's actually what we refer to as a haptic skill, where something is haptic is having to do with the sense of touch. So as you physically hold a pencil or pen or something else that you're sketching with, you are learning about what you're seeing. You're learning about the world around you. And that's if you're sketching from life, like if you're looking at something and sketching. But if you're sketching from your mind, you're sketching an idea, that also teaches you about the idea that you are pulling out of your mind, right? That brainstorming process is kind of coming through your hand out onto the paper through sketching. And just that very process, that practice of using your hand to sketch, it's like mimicking that process of building the building by hand. And so, until we have actual buildings that we inhabit only digitally, then sketching is still always going to be an effective tool, because it's still that physical relationship to what it is that we're actually doing. So you're using your hand to make something, whether it's two-dimensional or not. I mean, sketching is two-dimensional, but you can have a three-dimensional drawing on a two-dimensional surface, and so sketching can be two-dimensionally representative, or it can be representing three-dimensional objects but still on the paper. So this diagram kind of shows both. There's like the overall kind of plan views on the left-hand side of these four different schemes, and then on the right it's the three-dimensional sketched version of those. So even if you don't know how to draw, you don't know how to sketch, just putting pencil to paper or pen to paper and physically doing it is the first step. Because even if it looks horrible and it doesn't even look like what you had in your mind, if you've got an idea in your mind, you can keep sketching until that matches more closely to what it is that you had in your mind. Bubble diagrams are a really effective two-dimensional tool, and sometimes we use bubble diagrams early on in the design process to kind of group our ideas or organize space or organize our thoughts. It's not a floor plan, but maybe later on it will kind of influence the floor plan, but it's basically like taking each one of the spaces that are involved in the design problem. Maybe it's the spaces that you get from the program, but you put each one of those spaces in a bubble. And like literally it is just like a circle. Sometimes you color them differently. Sometimes you make them bigger or smaller sizes depending on how major or minor the space happens to be. But then you just kind of start placing them in relation to each other. Maybe you make big arrows connecting them. Maybe if you don't want them connected, you put the bubble farther away from another bubble. Maybe you have little connecting spaces or connecting bubbles. But it's just a really helpful way to organize your thoughts about the spaces that are involved. And sometimes if you have a pretty complex program, you can have a series of bubble diagrams maybe that group like spaces together, or maybe that you've got more major or minor or larger or smaller bubbles depending on what's going on with the program. And it's just a helpful tool for the designer. Maybe not, it's not even something that you might show somebody else. Maybe it is helpful to show somebody else, or you talk to the client about it. But it's certainly helpful for the designer to start to organize your thoughts about the spaces involved on the project. When we're talking about two-dimensional representation, a lot of times we're talking about line and shape, because if we're drawing something, whether it's digitally or by hand, we're trying to define the area that it inhabits. Now the first two on the left, these two drawings on the left, these are just quick, really fast drawings of a closed fist. So the person has their fist closed and then they're just doing really quick sketches. The one on the left is kind of a quick gestural line study, and then the one on the right is just where you kind of scribble it out and you don't even pick up the pen or the pencil off the paper. And then the one on the right is a more refined, continuous line study of a building where you don't pick up the pen or pencil off the paper at all, and just with a line, you're defining the shape of what it is that you're trying to represent. And obviously all of these things take skill and practice, but anyone can learn to try and do this with practice, because, you know, as you're taking pen to paper or pencil to paper, all you're doing is trying to mimic what it is that you're seeing. And so I really believe that if you start to practice in your mind and you train your eyes to connect with your hand, that's really the practice that needs to take place. And the only way you get better at it is by just continually practicing that. The composition of a two-dimensional element or two-dimensional representation is really important. And all that composition is choosing what it is that you're going to show. Now, this looks like kind of a haphazard sketch perhaps, but even this quick, rough, really kind of down and dirty sketch is still choosing what is going to be in the composition. So this is a sketch of a corner of a room, and the person drawing it has chosen to leave off part of the sofa. They've chosen to focus only on one corner of the room. They haven't done like other parts of the room. There's no door. There's maybe a window or a couple of windows back behind. So anytime you're choosing to place certain things in a view or on representation, you're composing what it is that you want the viewer to see. So composition is important. Composition is important in terms of controlling the views and controlling what the user is experiencing or thinking about or seeing when you're showing that 2D representation. Manual drafting is something that is very common when you're looking at two-dimensional drawing, and it's a skill that is really helpful to learn, again, for those haptic skills where you are learning about what it is that you're drawing by physically putting pencil to paper. Now, a lot of this has been replaced by computer-aided drafting, but just the habit and the physical practice of manual drafting helps you learn about projecting views off of one another, their relationship to each other, their connection to each other, and you see this pencil and the lead pointer and the sharpener, and even things like that teach you about line weight and profiling your drawing, meaning which lines you're going to choose to make heavier or thinner so that they read or pop out a bit better. And so manual drafting is still a valuable skill, even though it's not used as much as when it was totally necessary and the only form of drafting that was available, but it's still extremely useful and helpful to learn. Computer-aided design is often referred to as CAD, kind of its shortened acronym, but this is much of what's used in the architectural industry to produce two-dimensional technical drawings, such as elevations and sections, plans, all kinds of two-dimensional drawings that we use for early design communication and also later technical communication with the contractor or even the engineers or subconsultants, but it's an accurate way to measure out and depict what it is that the building's going to be. Now, computer-aided design is often used after you've gone through that ideation process and prototyping process, and then as you're kind of refining your design, you're using that in combination with all of your other tools. So just think of this as yet another tool. So sometimes it's used early on and later in the process. Sometimes it's used in combination with creating other three-dimensional representation, but it's yet another tool that's extremely common and used very widely in the architectural profession. Orthographic projection is a way of organizing two-dimensional information, and it's a bit of a leap because you're actually making a two-dimensional representation of a three-dimensional object. So the three-dimensional object here is the building itself. Now the building itself is going to be 3 dimensions in reality. Once it's built, it's going to be 3-dimensional. But in the process of communicating how it's measured, what its accurate dimensions and measurements are going to be, we often take surfaces of that 3-dimensional building and project them out. So it's as if we're pulling or extracting out the sides, the bottom, the top, and then we make these flattened 2-dimensional images or drawings of the building. And so the front and right and left and back sides that you see, it's as if we're taking actual points from the top roof portion, the walls, and literally kind of pulling them apart, projecting them out perpendicular from the surface of the building, and that flattened view on the sides becomes the elevation drawings or the elevation views. And we can look at this as the front elevation, the right elevation, but we could also look at it from the kind of compass points and say, okay, is this the north, the south, the east, or the west elevation? If my building is facing north and I'm looking at it, like let's say the front of it is facing north and I'm looking at that elevation, that would be the north elevation. So the back side, if that's facing south, that would be the south elevation. Same thing if the left side was facing east, that would be the east elevation. Right side, if that's looking west or facing west, that would be the west side. And then the top view in this case would become the roof plan because I'm looking over the top of that. The bottom view would be similar to the floor plan, but we'll take a look at what the floor plan actually is. The plan view, it's as if you are standing kind of inside of the building, but it's like you're looking down at the floor. That's where we get that idea of the floor plan. But it's like you took a chainsaw and buzzed a horizontal cut, like a horizontal plane, all the way through your building at about 4 feet above the floor and pulled the top of it off. And so it's like you're looking at that horizontal cut through the building, you're looking back down at the floor, and then everything that you see cut through, that's when you start to show like hatched or more heavily shaded lines for walls. Anything that gets cut through there is a heavier or darker line weight. And if you kind of squint your eyes, you can see where those walls are, because those are the ones that are more heavily shaded. An elevation view, it's like that orthographic projection graphic that we're looking at. It's a flattened side view of a particular surface of the building. Now, an elevation view is a flattened view, so we can actually pull the same dimensions off the floor plan and they will correspond exactly to the elevation view because we're showing the accurate length of that side of the building. A section view is effectively like a floor plan, except instead of kind of taking that imaginary chainsaw and buzzing through a horizontal plane on your building, you're cutting a vertical plane. So it's as if you're cutting from the roof all the way through the building, all the way down through the floor plate, the stairs, and foundation. And so all of that thickened gray area that you're seeing, that's what's cut through. This is almost like the dollhouse view. So the section, it's like you cut through and then you split it apart, and it's as if you're holding up that kind of half of the dollhouse and looking back in it. That's the section view. The scale of the drawing means whatever size, whatever proportional size from reality your drawing is going to be at. So what that means is if I am making a drawing of a building, I'm not going to make an actual 10-foot long drawing to, show or demonstrate a 10-foot long wall. I'm probably going to do a scaled down version of that drawing or of that building. And so if I have a 1/8 inch scale drawing, it means that for every foot in reality on the building, I'm going to represent each one of those feet with 1/8 of an inch. And so the scale on the right hand side is a special architectural ruler, which we call a scale, and it has different sizes depending on different scales of the drawing. So if you have a 1/8 inch scale drawing, then I would flip to the side that says 1/8 on the actual scale, and I could hold that up, and on that drawing I could measure how many feet and inches are represented by that drawing. Perspective, paraline, and oblique drawings, these are kind of the opposite of elevational drawings. So elevation drawings show a flattened side view of a building, but you could physically measure that elevation drawing, get an accurate dimension. But in a perspective, paraline, or oblique drawing, these are still two-dimensional drawings. It's like on a flat sheet of paper, but it's a three-dimensional view. So in perspective, I have the surfaces going away from me and getting smaller as if I'm looking at them with my eyes in reality. This is the way that we see in reality. We have, peripheral vision, we see in perspective. So perspective is a three-dimensional view that has kind of an imaginary horizon line going away from us, and things are getting smaller as they get further away from us in the drawing. Paraline views are also three-dimensional views but represented on a two-dimensional sheet. And oblique drawings are more similar to elevational views in that some of the surfaces are projected flat or perpendicular from the surface of the building in the drawing, but the things that are going away from us at an angle are shown in perspective. And then we have actual three-dimensional representations. Often that takes the form of models, but it's basically a scaled down version of the actual building that you want to represent. Now, study models are really critical to the design process. It gives you kind of a quick, down and dirty way to see what your idea is going to look like in 3 dimensions. Because you can do all the 2-dimensional drawings in the world, but you'll get a lot of kind of visual, quick design feedback for yourself if you make study models. And to me, these are kind of nice, cleaned up study models. They can be like this. This is made out of chipboard, or they can be, made out of cardboard and gooped up with glue and fastened with tape and pins. So it's just whatever you are going to use to give yourself some feedback. Usually the study models are kind of for the designer and like these kind of internal processes for maybe the architecture firm or your project team, so you can see what your ideas are going to look like. Now this would be like the prototyping phase of the design process or the design thinking process. So physical models are any models that you make with actual materials. They're going to be scaled down versions of the actual building. Now you probably aren't going to be using the actual building materials that you're going to use, but you're going to be using some modeling materials, and that might be wood or metal or maybe it's plastic or whatever it happens to be, but it's a physical representation of your building design idea. Now digital models are still representing your idea in 3 dimensions. It's just you're doing it digitally in the computer or some other digital format. And so you're typically using an architectural design software to assist you as a tool, just like any other tool, in creating a representation of what you might think that the end result is, or even just some design idea. But you can start to put scale figures in there to represent people and trees and other more realistic things. And then the last thing that we look at is building information modeling, or BIM. BIM is similar to CAD in that it's a digital computerized tool that allows us to accurately digitally model objects, but instead of it being 2-dimensional like in CAD, it's 3-dimensional. Now there's still some 3-dimensional objects in CAD, but what BIM does is it allows you to put actual building information embedded into the object so that you can get more accurate material information, manufacturing information, construction detailing, and it more closely interfaces with your construction documents and the construction process, and all the systems involved in the building, more closely mimicking and modeling what it's going to be like in reality once it gets built.